My name is Peyton Holston, and this is my presentation for Lab Draft 5, the Choose Your Own Adventure lab, where I chose to do an experiment similar to Lab 2 with a little variation. So in this lab, I decided to explore the motion of a falling object at 3 different masses to analyze how the drag force is affected by the changes in the mass. In this experiment, I used the final velocity, the final position, gravity, and drag force equations to calculate those respective values. This is just a sample of the code that I used, where essentially I took the mass of the ball that I measured with the scale, its initial position, and initialized the time and the change in time of each time step. This was different for each mass, of course, but this is just a example of the smaller mass where the bottle was empty. This is the time calculation loop where the forces of gravity and drag were updated over time, and the velocity and position were updated over time, as well as the time was moved forward with the t and delta t. So essentially, the primary analysis will come from looking at the drag force and seeing how the proportionality constant changes between each of the different mass values. So here we can look at just a little bit of the beginning data that I have. So this is the observed data versus model data without the drag force included. This is just simply for the smaller of the masses. So you see they're relatively close, but we use that proportionality constant to try and get it a little bit closer. In this case, we see it actually went farther away when you added a proportionality constant, which was interesting. I wasn't exactly sure why that happened, but this is basically as small as I could reasonably get the value. So I, just kind of kept that and moved along with it. Just gave it a very small value to see if it would maybe move closer. But essentially, it did not. It continued to move farther away from the final value and less accurate in compared to the observed data. So essentially, the conclusion that I reached in this experiment was that over the course of the changes in mass, the proportionality constant did not experience that much of a change, as its magnitude was already drastically small. But I'd also like to point out that the proportionality constant actually just didn't really help get a more accurate result in the observed model, which I found interesting, but I guess that could be attributed to some error in my code, possibly, or possibly just some error in calculation that I did. Not to say that there should be no proportionality constant, which I guess that could be possible, but the data that I collected was not suggestive or indicative that a proportionality constant would help gain better data in any way when outside of using just purely the velocity to calculate the drag force. So if I was to do this experiment again, I would go through the code again and make sure that everything is accurate there. Not that I didn't do that during this period of the experimentation, but just to check it again, maybe get someone else to look at it to see where my error was, and maybe get an object that's less irregular so I can get a more regular data set, because I think that also might have affected why adding the proportionality constant was essentially ineffective, because the bottle is somewhat irregularly shaped, so getting a object that's maybe more circular or has a flat surface on the bottom that is being dropped on could help explain why the drag force proportionality constant was so off, because of the way that the air flew around the bottle. That probably lends itself more to the proportionality constant not being exact because of the irregularity of the object that I dropped. But thank you so much for listening to my experiment.